Welcome back to Wisdom Academy. In today's video, we're going to look at the atomic numbers and the mass number of an atom. We're going to look at the numbers, the atomic number and both the mass number. Now, how do you know the atomic number? How do we determine, how do we ascertain the atomic number of an element or of an atom? Now, this we can calculate, or we can say based on the number of protons that the atom has. So if the number of protons is 11, therefore the atomic number will be 11. For example, sodium, in the case of sodium. If the atomic number is 5, if the number of protons is 5, it therefore means the atomic number will be 5. It means that the atomic number is determined based on the number of protons that are found in the nucleus of the atom. So the atomic number is ascertained based on the number of protons that are found in the nucleus of the atom. So if that is understood, it therefore means hydrogen atom always contain one proton. So it means atomic number of hydrogen will be 1. Carbon atoms always contain 6 protons. It means that the atomic number of carbon will be 6. The number of protons changes based on the atom as the atom increases in the periodic table, which we're going to talk about in our subsequent video. Now, the number of protons in an atom is known as the atomic number or the proton number. The number of protons in an atom found in the nucleus of an atom is known as the atomic number. So if we ask you to define the atomic number, you simply tell us is the number of protons that are found in the nucleus of the atom. The number of protons that are found in the nucleus of the atom is defined as the atomic number. For example, if you take a look at this carbon atom, the number of protons is 6. Number of protons is 6, and the number of the mass number, which is something else we'll talk about in a while, after a short while, it's 12. So the number of protons is 6. Therefore, the atomic number of carbon is 6. Now let's take a look at different elements. The atomic numbers are based on the number of protons of different elements. If you take a look at, if we write an element or an atom, the one the denominator, the one on the bottom side is known as the number of protons, and then one on top is the mass number of the atom. We're going to talk about the mass number, but at the moment we're talking about the number of protons. So the one at the bottom, the one on the bottom left side of the atom is the number of protons, and it connotes the atomic number of the element, because we said the number of protons equals to the number of equal to the atomic number of the atom. Now, for sodium, which symbol Na, natrium, from Latin name, derived from Latin name, the atomic number is 11. Why? Because the number of protons found in the nucleus of this sodium atom is 11. Now, what of for iron? The number of protons found in the nucleus of the atom is 26. Therefore, it means that the atomic number of iron is 26. Now, what of thin? The atomic number is 50. Why? Because the number of protons found in the nucleus of the atom is 5050. What of fluorine? Fluorine, the atomic symbol F, the atomic number is 9, because the number of protons found in the nucleus of the atom is 9. Okay, so that's great. Now let's move on to what's mass number. Now we understood the atomic number, because we've used two concepts to explain we've used these two concepts to explain the atom. Now we said, if you take a look at this carbon atom, the bottom one, the left side, it's the atomic number, which is the number of protons. And we said the top one, which is 12, in this regard, it's the mass number. Therefore, now we want to talk about mass number after we've taken a look at the number of proton, which is the atomic number. Now, the mass number of an element is the total number of protons plus neutrons found in the nucleus of the atom. Both the number of protons and the number of electrons found, both the number of protons and the number of neutrons found in the nucleus of the atom. So we say the sum of protons and neutrons found in the nucleus of the atom is known as the mass number or nuclear number. In some regard, or in some books, they call it the nuclear number in physics specifically. Now, so the number of protons plus the number of neutrons, which is actually the total number of particles that are found in the nucleus of the atom. It therefore means when we say the mass number, we refer it to the content of the nucleus of the atom, because in the content of the nucleus of the atom we invariably find the two categories of subatomic particles, which are the protons and the neutrons. So the summation of the number of protons and the number of neutrons found in the nucleus of the atom give rise to what we call the mass number. Okay, great. Now let's take a look at this magnesium atom. We already agreed that this is the number of protons, 12. And if the number of protons is 12, it means the atomic number is 12. Now the mass number, we say the one on top is the mass number. The mass number is the total sum of the number of protons plus the number of neutrons found in the nucleus of the atom. Okay, great. Now let's take a look at this table and begin to analyze this concept as it were. Now in the first case, we say the number of protons for hydrogen atom, the number of protons is 1 and the mass number is 1. Since the mass number of hydrogen is 1, it means the number of neutrons will be 0, because 1 plus 0 equal to 1. So that's why here is 0. If not, if this one was 2, it means here will be 1, because 1 plus 1 would have been 2. But because the mass number of hydrogen atom is 1, and the number of proton is 1, which determines the atomic number, it therefore means the neutrons, the number of neutrons found in the nucleus of that atom is 0. Now let's take a look at lithium. Lithium has a number of protons to be 3, which means the atomic number is 3, and the mass number is 7. It therefore means the number of neutrons is 7 minus 3, which is 4. Okay, now let's take a look at aluminium. Aluminium has atomic number 13 and number of neutrons 40. Therefore the mass number will be 27, because 30 plus 40 is equal to 27. For this, the number of mass number equal to number of proton plus number of neutron, which is 3 plus 4 equal to 7. For this, mass number equal to number of protons plus number of neutrons, which is equal to 1. 1 plus 0 is 1. Great. So this is for beginners to understand this concept. Now we therefore represent this as a formula. We say the mass number of an atom is equal to the number of protons plus the number of neutrons. The mass number is equal to number of protons plus number of neutrons. Now, what is the mass number of these atoms that we've highlighted? We have helium, we have copper, we have cobalt, we have iodine, we have germanium. Now, what are the mass number? First of all, we have to know the number of protons and the number of neutrons. Now, if the number of protons is 2 and number of neutrons is 2, the mass number will be 4, because 2 plus 2 equal to 4. Great. Now, let's take a look at copper. If the number of protons for copper is 29 and the number of neutrons is 35, it therefore means the mass number will be 64, because 29 plus 35 is 64. Now, for cobalt, if the number of protons is 27 and the number of neutrons is 32, it therefore means the mass number will be 59, because 27 plus 32 is equal to 59. Now, what of iodine? If the number of protons is 53, which is the atomic number of iodine, if you take a look at the periodic table. Now, the number of neutrons is 74. What will be the mass number? 127, because 53 plus 74 equals to 127. Is that okay? Great. What of germanium? 32 number of protons, 41 number of neutrons. The mass number will be 73, because this plus this equal to 32 plus 41 is equal to 73. Now let's take a look at building a nucleus. How do we build a nucleus? First of all, from the basic first 20 elements in the periodic table. We'll take a look at the first 20 elements in the periodic table. So we can easily identify for what we've said just now. Number of protons is 1, the mass number is 1. Neutron, number of neutron will be 0 in this regard, and helium 2 plus 2 will be equal to 4, and so on and so forth, like we've said in the basic first 20 elements that we've learned previously in lower secondary or probably even before then. So these are the, for example, the calcium, number of proton is 20 and number of neutron is 20, therefore the mass number is 40. So this is the basics, like we're looking at. Out more of this we can look in a bigger or proper periodic table. Now let's take a look at a small exercise to see if we understand how this number of protons and number of neutrons or electrons all work together and determines the atomic number or the mass number of an atom or of an element. Now, for example, if boron has number of protons to be 5 and neutrons to be 6, then the number of electrons will be what? We said number of protons equal to number of electrons. Remember in our previous video, we said the number of protons of an atom equals to the number of electrons of the atom. That's why an atom is said to be electrically neutral. We said this before. Therefore, here will be 5. And the number of protons is also equal to the atomic number. Therefore, this is 5. And the mass number will be 5 plus 6, which is 11. Now, let's find 11 in this place. We're going to find 11. The same goes to this. The number of... we know the number of electrons, therefore means the number of protons will be 90 as well, because number of protons equals to the number of electrons. If number of electrons is 90 and the mass number is 39, what is the number of neutrons? Is 39 minus 90, which is obviously going to be 20. Okay, that's good. So same thing goes to all of them, and this is the result that we get, and that's great. It means we understand how these different for different elements, how to calculate the number of protons, number of neutrons, number of electrons, the atomic number, the mass numbers, what all this terminology means, how to go about them, how to calculate them. Now let's move ahead. We now look at summary of our work, which is basically the terminologies that we've made measure of. We need to know their meaning. Like for example, the atom, we say is the smallest particle of an element which can take part in chemical reaction. It can actually take part in chemical reaction. Atomic number, we say, is the number of protons that are found in the nucleus of the atom. Now, also electrons, we say they are negatively charged particles that orbit around the nucleus of an atom. They found outside the nucleus of the atom, revolving around the shell. Okay, electron shell, we say they are layers around the nucleus of the atom. Electrons orbit around the nucleus of the atom in shells. Okay, now an element is a substance that is made up of only one type of atom. What's the difference between an atom now and an element? An element is a substance that is made up of only one type of atom. The atoms might be many, but they are just one type. You can have millions of atoms of that element, but it's just one type. It's not two types, but one type of atom that could be as much as it can. Okay, so that's what an element is. Now let's take a look at the mass number. We say the mass number is the number of protons and number of neutrons found in the nucleus of the atom. Then we say the neutrons. We say if you take a look at the nucleus of an atom, a neutron, it's that which is also composed or comprised or found in the nucleus with a mass of 1 and without a charge. Okay, the one that has a charge, which is positively charged, we said it was a proton found in the nucleus of the atom. Now, what of the nucleus? The nucleus is a densely populated, positively charged center of an atom. It's found at in the center of the atom. It's densely populated. Because why is it densely populated? Because it has a lot of protons and neutrons all found at the center of the atom. Is that okay? Okay, now what of the periodic table? The periodic table lists all the elements in order of the atomic number, increase the atomic number. It lists all the elements in increase the atomic number. Now what of the protons? A positively charged particle is proton with a mass of 1. Okay, now what of the proton number? The number of protons found in the nucleus of an atom is the proton number, which is also the same as the atomic number. Okay, thank you very much for being with us in our today's video. And before we go, let's take a look at this small exercise. If these statements are true or false. Neutrons and protons are positively charged. Is it true? Is it true? Neutrons are positively charged. Atomic number is the number of protons in an atom. That's true, right? And then we said the atomic number is the larger of the two numbers shown in the periodic table. Is that so? The larger of the two numbers, atomic number? That seems not to be true, okay? Now the mass number of an element is the number of protons plus the number of neutron. Yeah, proton plus neutron equals to mass number, right? That appears to be true, right? Now each element has a fixed number of protons. That's true, right? Now let's check what yeah, that's great. It means we were right in our decisions, or we have a good understanding of this topic. So we can also look at this multiple choice and see which of the following is not part of the atom. Which of the following is not? The proton, the neutron, and the electron, they are all part of the atom. Okay? Okay, the isotope. Because isotope we didn't mention in our topics today because it's a subtopic that we're going to take a look at. What if, and so on and so forth. We have so many other questions for you. Why do atoms have no average charge? Why do they not have average charge? Because number of protons equals the number of electrons, right? Therefore, atom is said to be electrically neutral. Now, which atomic particles are found in the nucleus? Which one are found in the nucleus? The protons and the neutrons. The electrons are found outside, right? The electrons are found outside. The protons and neutrons, right? Now, which an element's atomic number is the number of what particle? Protons, right? Yeah, that's great. So these are some questions for us to always get our hands up. What of the number? Which mass? The mass number tells you what information about the element. The mass number tells you which information. What does it tell you? The number of protons plus the number of neutrons. That's right? That's great. Now we see to another question. The carbon has atomic number 59 and atomic number 27. This means that carbon has what? It has a mass number, sorry. This is a mistake. It has a mass number of 59 and atomic number 27. And then what does this tell us? It means that the neutron is 59? No. Proton is 27? Yes. Proton is 27. Electron is 59? No. Neutron is 27? No. Because 59 minus 27 gives the neutron. So, but proton is 27 because this is the atomic number. Right? Great. So, all these questions for us to have a hand of. An atom of chlorine has 70 protons and 18 neutrons. How many electrons does it have? We said the number of protons equals to the number of electrons. If the number of protons is 17, it therefore means the number of electrons is also 17, right? That's great. So you can see how it works. How this, which scientists introduced the idea of atom in 1803? Is it Democritus? Is it James Chadwick? Ernest Rutherford? John Dalton, right? John Dalton. He introduced the idea after Democritus did it in 450 BC. Now, so on and so forth, questions for you to practice and have a handout. Thank you very much for listening to our today's video.